This video takes a brief look at outliers and is a continuation of the video on correlation. Outliers are extreme values that may distort the results of such simple statistical tests as correlation. On SPSS, a researcher can request diagnostics, but the options are not built in. You have to ask for them. Let's look at some examples of how a single extreme value can violate the assumptions of normally distributed data. Here's a set of data that I copied from a series of diagrams in a textbook. These 13 cases have x as the independent variable and y as the dependent variable. If I choose Analyze, then Correlate, then Bivariate, making sure that Pearson's box is checked and that my two variables are entered into the right-hand box. Click OK. The result is a fairly tiny r equals 0.21 after rounding to the hundredths place. 0.21 is close enough to 0.20 that squaring it gives a coefficient of determination of 0.04, or about 4%. Not a huge influence of x upon y. To plot the points, I choose Graphs, then Legacy, and then Scatter Dot for my scatter plot. I use a template to force the display into a 20 by 30 area. The 13 cases form a tight cloud of values that vary with the increase in the independent variable x. To see a line, I double-click on the graph and choose the menu item Elements, then Fit Line at Total. The unimpressive slope betrays the mild direct connection, and the chart displays r squared equals 0.044, or 4.4% change in y explained by x. Look what happens when I introduce a 14th case in different quadrants of the graph. You can see the 14th case lies outside the other cases, which is why it's called an outlier. Note the slope and r squared vary considerably from upper left to upper right to lower right and lower left. To test for outliers visually is okay for small data sets, but SPSS gives you outlier diagnostics and normality plots. Correlation of two variables is the same as a linear regression of two variables. So choose Analyze, then Regression, and then Linear. Make sure that the x and the y variables are your independent and dependent variables. First choose Statistics and make sure that the case-wise diagnostics box, which is normally unchecked, make sure that it's checked. The default value is normally 3, which only detects extreme outliers, so I made it a 2. Had I chosen 1, it would detect mild outliers. So 2 is the Goldilocks just right choice. Click Continue and choose Plots. The normal probability plot box is turned off by default, so you have to make sure it's checked, and then click on Continue. Click on OK. You must look for a table that might appear between the coefficients box and the residual plots. In this example, there is such a box labeled Case-Wide Diagnostics. If there is a medium-size outlier, the exact case number will be identified. And for me, it's the 14th case that I entered. Each of the other outliers I showed you also identified case 14 as an outlier. Next, scroll to the PP plot. Notice that the dots are noticeably erratic. Compare this with the PP plot of just the 13 cases without the outlier, and you'll see that the dots are close enough to the line to assure you that your data are normal. So what do you do with one or a tiny few outliers? If you can, just delete them from your analysis and then provide a justification in your method section. Maybe the person answering a survey for that case lied or was just so abnormal as to distort the vast majority of cases. But you have to admit to such deletions in your report. The reader will appreciate you're trying to make it a fair test of correlation. Outliers distort your findings. Homoscedasticity is a measure of how orderly the variance of data is. It is desired for standard tests using parametric samples. With heteroscedasticity, data appear in odd shapes like this, where a range of values deviates from an orderly pattern. Using a scatter plot can help you detect these problems. That's it for Outliers. See you next time.